Now that you have learned what the concept of a derivative is and the definition, and if you haven't, you can check back to the previous video, you may be asking, how do I differentiate a function? And thanks to some really famous mathematicians, they have developed straightforward formulas to differentiate a function without the use of directly using the definition itself, right? Which can be sometimes be extremely complex, right? So the first one we will be talking about the power rule, where it states that for x, let's say y equals x, dy dx, which is the differentiation notation, equal to nx n minus 1. Okay, how do we make it more concrete? So for example, y equals x to the power 2 of 2, x squared. Then we put dy dx equal to, we take this and bring down, okay, 2x, then 2 minus 1, 2 minus 1 equal to 2x 1, which can be literally written as 2x, right? So why does this work? Well, if we use the definition of the derivative here, where limit as h approaches 0 for f of x plus h minus f of x divided by h. Then we input f of x plus h as the x, right? We get a limit as h approaches 0 for x plus h squared minus x, right? Then we divide by h. Okay, now we can expand this, right? Limit as h approaches 0, x squared plus 2hx plus h squared minus x. Sorry, this is x squared, my bad. Minus x squared divided by h. So we can minus this off, and we get limit as h approaches 0, 2hx plus h squared over h, which we can simplify for the limit as h approaches 0 for h, 2x plus h over h. Then we can cancel off. Then we get limit of h approaches 0, 2x plus h. And if we can evaluate h approaches 0, we can directly input this as 0. So we get equal to x. And there we go. Same thing. Right? Great. Okay. Now, if there's something else I need to address, and that is how do I differentiate a constant? K, right? Let's say if you want to differentiate, and it's pretty simple. You differentiate a constant k, is always equal to 0. Okay, for example, y equal to 5. If you want to differentiate dy dx equal to 0, even if it is a 5 million, it always becomes 0, right? Now, I will be adding the next rule, which is also pretty simple, is the sum rule, right? And what this states is that for, let's say you wanted to differentiate f of x equals to x5 minus 4x, right? Simple, right? So we get the differentiate f prime x, which is also the notation to differentiate a function, is f x4, right? If we differentiate the first part, then minus 4, right? Because we differentiate the second part. The same applies to, let's say, let's use another one, g of x equals to, let's say, 2x squared plus 5x plus 1. Okay, how do I differentiate this? Well, remember that all the rules we learned just now, g prime x, my bad, g prime x equal, bring down 2 multiply 2, 4 x, 2 minus 1, 1 plus 5 plus 0, because you know whenever we differentiate a constant we get 0, so that's how it works, right? Now these are just some of the main key rules, but there will be more in the next video. But before that, I want to get into some exercises we can do, right? So for question 1, y equal to 5. How do we differentiate this? Well, remember it's a constant, dy dx always equal to 0. Then for question 2, now f of x equal to 5x 18. Well, how do we differentiate this? Well, f prime x equal to, well, you will take 5, then you bring down the 18, x, 18 minus 1, 17. Equal 5 times 18, well, I haven't got a calculator with me, so this is what I gotta do, right? So it will be 90 x 17, right? Great. Now, question 3, y equal 4x 5 plus x. Then you differentiate it, dy dx equal to 5 times 4, 20, x 5 minus 1, 4, plus, if we differentiate x, we get 1, right? Because x power to 1, we bring 1 down, 1 minus 0, x power to 0 equals to 1, right? Alright, great. Question 4, we have f of x equal to 4x power 4 minus 5x minus 3. We differentiate f prime x equal to 4 multiplied by 4, 16, the x 4 minus 1, 3, minus 5, because, well, differentiate x, you get 1, and minus 3, nothing, right? Great. Now we'll move on into slightly more complex questions, right? Let's see. For question 7, we have y equals negative 4x power negative 5. Now, I'll give you a moment to try to do this yourself as a challenge. Alright, assuming that you've given it a go, I will be showing you how to do it. So before, okay, now with dy dx equal to negative 5, bring down, multiply by negative 4. What do we get? Negative, we will get positive. So 5 times 4 is 20, so 20x. Then negative 5, we get negative 6 minus 1. Right? Pretty easy. Should be pretty straightforward. Now, 8, y equals to 3 divided by x power of 3. What do you think? Right? I know maybe some of you, it's quite easy for most students to differentiate. Oh, I'll probably get that 0 over 3x squared. But that is wrong. Couldn't be more wrong, right? Let's not do this. So what do? We write it into the simpler form first. Well, now we remember that 1 divided by x equals to x power of negative 1, right? Pretty straightforward. So we write it in another form, where we take 3 x, because it's x power 3, but it's 1 over x power 3 equal to x negative 3, right? So x negative 3. Now after, how do you differentiate this? Pretty simple, right? Just continue. Bring down 9, negative 9, x minus 4. And if you want to write it in this form, the quotient form, it's pretty easy. Just take negative 9 divided by x power 4. Simple, right? Now, for question 9, y equals x power 2 over 3. Differentiate it, dy dx equal to 2 over 3 x, 2 over 3 minus 1. Well, that will get you 2 over 3x. 2 over 3 minus 1 is... 1 over 3. Negative 1 over 3, I believe. question 10. We have f of x equal to negative 2 cube root 4 power 4 of x. Okay, this may seem a bit complex, but once you get the hang of it, it should be pretty simple. Okay? So, remember, for the square root of x, we get equal to x to the power of half, right? So, for the fourth root of x equal to x power of 1 over 4. Okay? So, equal to negative 2 x power 1 over 4. Right? Then we can always just differentiate this f prime x equal to negative 2 multiplied 1 over 4x. Then 1 over 4 minus 1 equal to negative 3 over 4. Negative 2 multiplied by 1 over 4, I assume is negative 1 half x negative 3 over 4. Now, if you want to write it in a more into this form, into a root form, is equal to 1 half multiplied by, well, remember that 1 over 4 of x is fourth root of x, so we can just take, now we have, remember this, we have a negative, so negative 1 equal to, then we also x, negative 1 equal to 1 over x, so remember, this is 1 over, well, fourth root of x cubed. So we get negative 1, 2, fourth root of x cubed. This is a bit more complex, but hopefully you get the gist of it.